By studying life in extreme environments here on Earth, we may be able to get an idea of what life would be like out there. There might even be life in our own solar system, perhaps even on our closest neighbor, the red planet, our ruddy buddy, Mars.
We're standing on Little Red Hill.
Little Red Hill.
It's my favorite place on Earth because it's a lot like Mars, actually. It's red and it's mostly lifeless, but in fact, this little square we're standing on is teeming with life. Underneath these rocks, say this one for example, you see that layer of green? These are algae that are living under the rocks. They live under the rocks because the rock traps moisture, so it's a little wetter under the rock than it is in the soil nearby.
Just that much wetter.
Yeah, so this is a rock I broke earlier. You open it up, it's white inside. The light comes through the red layer, goes through the right rock, and reaches the algae. So they're living under little rock greenhouses.
So how much light gets through there? I mean, 5%? 1%?
About 1%. In fact, if you hold it up to the sun, you can sort of see the sun coming through it. If you look at it through the magnifying glass, you can see it. It looks kind of like grapes, little clusters, little balls. And in fact, adding a little water makes it really clear that it's a set of cells rather than a mineral deposit.
It looks like moss.
Yeah, tiny, tiny moss.
Yeah. Now, how did these organisms come to be here on the Earth?
Well, these are some of the oldest organisms on Earth. They're the most ancient. We find them early in Earth's history, these type of cyanobacteria, they're called. In fact, these bacteria are the ones that are responsible for the oxygen in our atmosphere. These are the only other species besides humans that are capable of changing a planet. They changed it by making oxygen 2 billion years ago. And these are the organisms I'd really like to find on Mars. Because if there were organisms like this on Mars's history, well, maybe Mars could have had the kind of changes that Earth has had. There's really good evidence that Mars at one time, maybe long ago, had a lot of water on the surface. We see gullies that don't have any water in them now, but have all the signatures of water having flowed through them. So we see dry rivers, dry lakes, and maybe even dry ocean floors. And since water is what life needs, that's why Mars is interesting.
This is sodium bicarbonate. You find it in the rocks around here. It's what chemists call a base. This is cream of tartar. It's made from grapes. It's an acid. Now, when acids and bases mix, they often react. But you can see there's no reaction. There's no way for the electrons to get from one atom to another, no way for the atoms to interact. But watch what happens when we add water. Now, they're reacting like crazy. So for life, just add water.
Tommy, what is the most important thing for life as we know it to exist?
Wood?
Mary?
Is it liquid water, Mr. Sanders?
Very good. So, where should we look for other life forms in the universe?
We should look in...
Wait, let's see if Tommy has an answer that will get me big laughs in the teacher's lounge.
We should look for planets that could possibly contain water.
Gee, Mr. Sanders, Tommy got it right.
That was excellent.
Don't hit me, Mr. Sanders.
I was not going to hit you, Tommy. I was just patting you on the head.
Ah!
Well, I guess Tommy is not feeling well, so let's return to more of the Eyes of Nye.
What if we found life on Mars?
Well, it'd be interesting. It would tell us, well, here's another planet with life. But the real question would be, is it the same life? See, these guys and us, we're the same. The genes in these algae are very much the same as the genes in your cells and in my cells.
They have DNA.
They have DNA. And it's got the same alphabet that we have in our DNA. And it's the same words in their genes as in our genes. What if we went to Mars and we found some organisms and they had a completely different alphabet, completely different words in their genes, completely different chemistry? Well, that would be interesting, because then we'd have two really different types of life. When we go to Mars, we're not just searching for life, we're searching for alien life. We're searching for something that's different.
NASA C.
NASA C is ready.
NASA MEM.
SMM ready.
SMA?
SMA is ready.
This rocket is the product of huge investments in both money and manpower. And you might say, what are you going to find out there, millions of nautical miles away? Well, we don't know. That's right, we don't know. We know what we're looking for, but we don't know what we're going to find. Mars is an unknown horizon, a new frontier. This ship is going places we've never seen. This is the human imagination at its best. Exploring, seeking, working on that question. Are we alone?
4, 3, 2, main engine start, 0, and liftoff of the Delta rocket with Opportunity, a chance to explore and unlock the secrets of our neighboring planet.
Of course, anybody who's been to the movies can tell you
You got company.
there's life in outer space.
What terrors of the deep await the exploring spacemen? Underwater creatures swarm from the depths to exact their primitive vengeance upon the invaders from Earth.
If aliens are anything like you and me, they live on planets. See, they can't live on stars because the energy coming off the surface of a star is so intense it incinerates molecules. So we figure aliens live on planets going around distant stars. Now, distant stars are, well, distant. So any planets that are orbiting them are too far away, too small, and too dim to see. But there are people working on it.
I'm Dr. Deborah Fisher. And my job is to find planets around nearby stars.
And you have found some planets.
That's right. Collectively, astronomers in the world have found about 100 planets now orbiting other suns, other stars. And our group has found about 70 of these.
70 planets. Now, what are these planets like?
Well, they're different from our Earth, much different, because the technique that we use is actually more sensitive to finding large gas giant planets like our Jupiter, which is 317 times the mass of our Earth. So it's these large planets that we're finding.
What made you start looking for these things?
We're trying to find out if our planetary system is common, if it exists, if there are platforms for life around these other stars. Because before 1995, for all we knew, these stars were just desolate, bright objects up in the sky.
It wasn't until 1995 that a group of Swiss astronomers detected the first planet orbiting a star much like our own sun. This was the first direct evidence that planetary systems like our own are not unique. There may be planets orbiting stars all over the universe. How do you go about finding a planet on another star?
Well, unfortunately, what we'd like to do is go up and take a picture of the star and see the planet sitting right next to it, and then in one night we'd have the front page of the New York Times covered. But instead, we actually exploit the laws of physics a bit.
We measure the speed of all kinds of things thanks to a discovery by Christian Doppler. Listen to this. As the ringing moves towards you, it sounds higher pitched.